This is Mike Lawless, and in this video I'll demonstrate how to cluster a set of BACE1 inhibitors in order to create classes that contain the same scaffold. We will then generate an R table for one of the classes and analyze the compounds. Finally, I will show how to enumerate the R table in order to combine all of the substituents in one position with all of the substituents in the other position. I'm starting with the set of 884 BACE1 inhibitors that were extracted from the Kimball database. I have two columns here containing the activity data. They're both related. This is the raw data in nanomolar quantity, and so it goes from about 200 picomolar all the way up to 220 micromolar. So a good way to visualize this is to create a heat map of these two columns. So I'll just check all and create that heat map column. Now if I sort in ascending order for the IC50, you'll notice that the low IC50s are red. Typically red's bad, so I'm going to set that direction to descending, and that will show the low nanomolar compounds green and the more inactive compounds in red. The next thing I'm going to do is cluster these compounds into classes. And so I can simply go to this menu bar up here. This is using the MedChem Studio module of ADMET Predictor. And there's several ways to bring up the class generation dialog box. One way is simply to click on this icon here. So there are various ways to generate the classes. The fastest way is the frameworks, which is the default method. So I'll click that, and if you're in the Compounds tab, it adds a column, tells you some information about the column and how to activate the various classes. We can also use these controls up here to navigate through the various classes. So if we push this one, it will display the compounds in the first class. So this is C1, and there's 63 compounds in this class. We can move to C2, where it's only a singleton, and then just start going through these. Now if we want to see all the classes together, we can click the green button, so it shows the 884 compounds with the scaffold highlighted. We can also select the red button, and it'll just simply display all the compounds but won't highlight the scaffold. So this is essentially going back to the view before you generated the classes. If I click on the Classes tab, the classes again come up grouped into or each of the rows now represents a class. So this first column, so let's undisplay this R table column. So this first class has 63 compounds in it. This is the distribution of the formula weight, which isn't particularly interesting. So I'm going to set the contents of that, or excuse me, modify the plot so that we're plotting the PIC50 for these compounds, or for this class. You'll see that it's shows some fair activity. This is the average PIC50 for the class, and this is the average IC50 for that class. Another way to generate classes is to use this ring anchored system. So let's try that and see what that'll come up with. This is a little bit slower method, so it takes a little bit longer, but it's still quite quick. And you'll see that now it's generated 236 classes, and it's just identified this smaller imidazolone ring with a phenyl substituent on it. Now let's go back to the original frameworks class and generate those, because those look fairly interesting. So if you look at this first class, you see it's got 63 compounds in it. It's the imidazolone ring along with the two phenyl rings. This next compound is kind of similar to that, except it's got a pyridine ring in it. And if you start examining some of these, they all have the imidazolone, and the substituents vary. So let's see if we can create a class just based on the imidazolone ring. So what I'm going to do is take this first compound, and I'm going to copy the structure as a SMILES string. I'm going to go back into the Compounds tab where all 884 compounds are shown. And then I'm going to go to the Edit and Query dialog box, bring up MedChem Designer, paste that structure in there, and then I'm going to strip away some of the substituents because I only want to search for the scaffold. Then I click the arrow with the X on it. That'll close MedChem Designer and bring the molecule back into the search query dialog box. I click OK, and we see that I've highlighted 195 compounds. So I want to work with this class sum, so I'm going to delete all the rest of the molecules in the data set, and I can simply, the first thing I want to do is go into Edit and invert the selection, and you can use Control-I to invert the selection, and then I'm simply going to delete all of those compounds just by hitting the delete key. All right, so now we've only got 195 compounds in the data set, and this might be a good time to save this or save as. I'm going to save it kind of as a BAC50 IC50 195 because there's 195 compounds in here, so that's a good idea to save them. Now let's go into the classes tab and just generate a super single class out of all of the compounds in here. So now we've got a single class, and I'm going to use the generate Marcouche MCS feature to kind of investigate this class a bit more and try to understand what's in that data set. So it's generating the scaffold. Now it's highlighted some blue atoms. These red atoms are from the query. So I'm going to go up to view and remove that query highlighting by doing the clear query highlighting. Now we've defined Marcouche MCS, and to investigate it a little bit further, we need to generate the R table. So the R table comes up, and it's defined a couple substituents off of this carbon and 3 substituents off of this carbon. The amino group has a methylene group and then some substituents, in the 4 position. So let's take this into the R tables where it quickly converts the R groups into individual columns, displays those. So it's generated this amidine group, adamantane group. So it's just all those substituents are the same, or the R groups are the same. Let's sort on this R1 group in ascending order and then descending order. So here's kind of an interesting compound that's got a tricyclic group here. And I'd kind of like to remove these type compounds. So what I can do is go back into the Compounds tab and perform another substructure query and specify that this ring atom here can only be in two rings. So I'll right click on it and set the ring bond count to 2. Now when I go back into the data set, I click OK. It's identified 193 out of the 185 or 95 molecules that are only that atom is only in 2 rings. So I'm going to invert that selection and then move the compounds that are selected to the top. So when I inverted it, it highlighted all the molecules that didn't have this particular substructure in it, and then I use the command Control-T to move these to the top. So there's a view, there's a menu item for that under the Edit button, or under the Edit pull-down menu called Move Rows to Top. So I simply use Control-T quite often, so it moves the selected rows to the top so that we can see them. And so these aren't molecules I'm particularly interested in, so I'm going to delete those 2 compounds, and then go back into the Classes tab, and again redefine the scaffold as a just this imidazolinone ring. So I go into Classes, Scaffold, Define with a lasso, and this time I'll just lasso it around again and define it. And also I want to clear the structure highlighting so that we see the scaffold here in blue. Okay, so when I analyze these molecules, I prefer this amino group to be over on this left side. So I can take this molecule, this representative molecule in the sketcher, and this is how I want it oriented, but I want to flip this around. So I go under structure, flip, horizontal, and that'll move this group over to here. I also want to kind of straighten up this carbonyl group. It's kind of bent a little, and that's kind of annoying for me, so I'm going to highlight it, and then if I click on this cleanup button, it orients it so that it looks much nicer. Now I'll highlight the phenyl and move that back in, and then take that back into ADMET Predictor. It reorients the molecule. Now if I right click and go down to align compounds, it aligns each one of these compounds together. So we can go back in the compounds tab, and you'll see that these are highlighted properly. If I click the green button, you'll see that it highlights the scaffold. Now I go back into the class, and I'm going to make that column just a little bit wider, and then generate the R table for one final time. Now I've got three substituents off of the molecule. It's oriented in the manner I want. Now go into the R tables dialog box, and now we have R1, R2, R3. These numbers in the parentheses are the number of unique substituents at that particular position. Here we can do a little bit more analysis by adding a family column. So I'll go up to the R tables and generate a family column. And what this does is it creates families where in each family a specific group is allowed to vary and the other groups in the molecule are held fixed. And that allows you to analyze the R groups at that one position, and you'll be able and you'll know that everything else is fixed. So any difference in activity is simply due to the change in that particular R group. So let me look at the R1s, or explore the R1s. So I click OK, and now if you look at this particular family here, and I'll make all these a little bit bigger, you'll see that the R1 group varies, but R2 and R3 are always going to be the same as I scroll through here for the first family. Now when I get down a little bit further for the second family, now we've got this biphenyl substituent in the R1 position. Again, let me make these a little bit wider here, and pyridine in the R2 group. Now if we sort this column in ascending order for the R group, R1 families, and then we can either hold down the control button and click on the IC50 column and see that the first few rows have an IC50 of 10 nanomole, very potent compounds, and it just looks like this substituent out here is just kind of a long alkyl substituent, although you have a phenyl group here now, or this kind of bi-aryl group here, also quite active. Now let's go into what we call the R group analyzer. So this has several different tabs up along the top here. In this first tab, it's showing all the 93 R1 substituents, and then the number of molecules that's in the data set. So for R1 equals phenyl, there's only one compound in the database. For R1 equals phenyl, or excuse me, pyridine in the 4 position, there's only one compound. This one has 8 compounds in here. And if I double click on that, I can view those 8 compounds in the viewer. Similarly for R2, we can display the R2 groups, R3. So you see that there's several different R3s. Most of them are a methyl group, but we've got this heterocyclic saturated 5-membered ring of phenyl, etc., down in through here. We could also display the molecules as the R1s as a column, and the R1s as rows, and the R2s as column. And we can color this by different properties. I'm going to color it by PIC50 values. We can also look at R1 versus R3 or R2, so we can look at all the pairs of R groups here. Now when you see something like looks like it's divided into a pie, the R1 and R2 are what's shown in here, but maybe the R3 group is varying, and you see some of these, the R3 group is varying for these compounds right there. And you can see that this is the least potent of these compounds. All of these with these two particular substituents are pretty nice in here. We've also got a way to display the R1 versus R1, and this enables you to kind of look across a particular row and see that if you change the R1 into this pyridal, you can compare the PIC 50 value change in activity for those two compounds. Now I want to explode all these so that I want to combine all the R1s, R2s, and potentially all the R3s, so that this group here is combined with all 58 R2s and all 7 R3s potentially. So I'll go up to the R tables and pull down menu and select explode products. Now, why I say potentially, there's a lot of these, and I just want to go with these because they're simple. So I can highlight the groups that I want to disable. So it's this one, I'm holding down the control key, and then these other compounds here, and I'm going to disable. If you notice, the estimated number of products dropped drastically because now it's only an R1 versus R2 combinatorial explosion as opposed to an R1, R2 combinatorial explosion. We have various options up here. There is a maximum number of products to explode, so if you reach this, you want to increase that. I could remove products that are already contained in this class. I'm not going to do that. And then finally, we can display the results in a new window. So just click OK. And that enumerates all of the R groups, combines all the R1s with all the R2 groups, and then brings up the results. So it created 5,328 compounds. We can go into the Classes tab and generate a single superclass. Click here to define the scaffold. Again, scaffold using a lasso. Now here I'm going to include that methyl group because that was all those substituents will be the same in there, and then generate the R table again for these exploded products. And then when we go into the R tables, the R tables tab here, we see the substituents here, and furthermore we can go into the R group analyzer and look at the RM by R1. So this is enumerated all of them. So why are some of these products missing? It's simply because of the symmetry of the scaffold. So if you have R1 as a pyridine here and R2 as a phenyl, you're only going to get that one match twice, a single time. Okay, so that wraps up this video on creating classes, generating R tables, analyzing the R groups, and exploding the products. Thanks for watching this video. If you want more information on Simulations Plus, please click on this link. If you'd like to send me an email, you can at mlawless@simulationsplus.com. And if you'd like to evaluate any of our software, please click on this link and fill out our software evaluation form. Thank you very much. This has been Mike Lawless, and I'll catch you next time. Thank you.